Have you at any point inspected whether we're truly alone in the universe or, on the other hand, if there's something more to our existence than what we see? Envision a situation. What if the James Webb Space Telescope, JWST, finally shows that we live inside a black hole? Join us as we explore more about this world, spreading the word that will make you question all that you thought you had some discernment of regarding the universe. So, what exactly are black holes? They're like something out of a thriller. Sure, you might have seen them in sci-fi films, but what's even more disturbing is that they're not just a fictional concept. According to well-informed authorities, black holes in space are truly gigantic amounts of matter compressed into an impossibly tiny region. Imagine a star several times more massive than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for a long time. At first, they thought of them as objects in space so massive and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a giant star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Identifying black holes is no simple task since they emit no light. However, scientists have found ways to interpret their presence by observing their effects on neighboring matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull matter towards it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, produce strong beams of radiation, and even influence the formation of new stars in some regions, while suppressing it in others. So, how do black holes come about? Picture this: stars, once bright and shining, meet their fiery end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, stars that are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these massive stars break down, something unusual happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the final defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours on Earth. Occasionally, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, it creates an epic nightmare that defies understanding. Scientists have been grappling with the size of these cosmic phenomena for years. Black holes come in two sizes, large and small. There's a bit of a misconception about them, though. Small is relative when it comes to black holes. Very large black holes, remnants of giant stars, can be as much as 10 million times the mass of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's an immense number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are at the outer limits of the spectrum. They're millions, if not billions, of times bigger than the Sun. These reside at the centers of large galaxies, including our own Milky Way. They seem like a massive dead space, pulling everything towards them. The renowned physicist Stephen Hawking discussed black holes throughout his life. His theories were well established, though some of his ideas proved difficult to confirm due to a lack of advanced technology. But now there's hope on the horizon. Not too far off, a single revolutionary instrument is changing everything. It's called the James Webb Space Telescope, JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human ingenuity. Sure, we've launched other space telescopes before, and they've done their job well, but this extraordinary machine is on a level that's truly remarkable. The JWST makes the Hubble Space Telescope, which has served us for a long time, look like a basic piece in the universe. The retail price of this astronomical wonder is an astounding $1 billion. Yes, you heard that right, that's a staggering number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with tremendous contributions from over 300 universities. However, we shouldn't forget the risks that come with such a grand project. This is not a venture for the faint-hearted. The JWST is venturing into an unknown world, pushing the limits of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made numerous incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sun shield and large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after aligning and calibrating, the telescope is almost ready for full operation. One of the most exciting parts of the James Webb Space Telescope was when NASA announced that it had captured its first significant pictures of starlight. The first picture taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light gathered by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446 in which 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory fine-tunes the individual sections of the primary mirror, it will begin the process of stacking images on top of each other to form one clear view. Thanks to its sophisticated technology, the JWST will help researchers study the early stages of the universe following the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to detect due to how they interact with their host stars. Powerful observations can now closely study these planets, allowing scientists to analyze their atmospheres and explore the conditions necessary for life. The JWST's capabilities can help scientists better predict whether specific planets might be habitable. Beyond focusing on planet formation, scientists study these worlds to understand how matter is structured on a massive scale. This, in turn, helps us understand how the universe has evolved, forming the galaxies we see today over billions of years, from a variety of shapes. One of the JWST's goals is to look back at the earliest galaxies to better understand how they evolved. Researchers are also trying to determine how we got the collection of galaxies we see today, and the ongoing processes that lead to the formation and merging of galaxies. Ultimately, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt. And guess what? It has found compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures appear to be the goths of the universe. They're found everywhere, from distant galaxies to comets in our own solar system. Now, they're not just fascinating because they could form the building blocks of life, but also because they help science track star formation. When bright radiation hits these PAHs, they become excited and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is often a sign that there are some hot, energetic stars nearby. But wait for the astonishing twist. A bold astrophysicist, Ismael Garcia Bernard from Oxford University, decided to investigate 3 interesting galaxies, NGC 6502, NGC 731, and the Eili Beautiful Stefan Quintet, as well as NGC 749. These galaxies are millions of light-years away, deep in the depths of darkness. What Garcia Bernard discovered will send shivers down your spine. In those central areas where the black holes reign, he observed an abundance of PAHs. Sounds interesting, right? Well, here's where it gets chilling. The radiation near these massive black holes altered the structure of the PAHs, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into nothingness, being consumed by the very darkness. However, the larger PAHs survived, finding refuge within thin, dense gas clouds. It's as if they found their own protective shelter against the fury of the black hole's pull. Now, you might wonder why this dark twist matters. Well, for space scientists who rely on PAHs to track star formation, it's a huge deal. Star-forming regions are often completely saturated with electrically charged PAHs. And if those particles are destroyed near black holes, tracking star formation becomes a real challenge. But don't worry, our dedicated space researchers aren't backing down. Garcia Bernard and his team are eager to dig deeper into this dark abyss. They want to study more galaxies, each with its unique twist, to uncover the secrets of how these remarkable PAHs survive in such extreme environments. They're determined to explain the specific properties of PAHs hiding within the black hole zones of destruction in galaxies. And hey, here's another game-changing discovery from the James Webb Space Telescope. It has detected what might be the oldest black hole in the universe. This colossal monster is an exceptionally large black hole, weighing in at a stunning 10 billion times the mass of the Sun. The JWST managed to detect it by identifying faint glimmers of light dating back to the very beginning of time itself. This eerie, forbidding discovery was made at the center of a young galaxy just 570 million years after the universe was formed. And get this, cosmologists believe there might be even older black holes hiding in the depths of space. It's fascinating, though unsettling, to think about what other revelations could be lurking out there, waiting to be discovered. One thing is certain. The James Webb Space Telescope is providing us with a glimpse into the darkest corners of the universe. And what we're uncovering is nothing short of mind-blowing. The discovery of the oldest black hole known to mankind has sent shockwaves through the scientific community. This massive beast could very well be one of many black holes that existed during the infancy of the first light, a period that began around 100 million years after the Big Bang, when the universe was just a billion years old. Cosmologists are puzzled by the sheer number of these black holes and how they managed to grow to such titanic sizes. However, the researchers who found this latest black hole published their findings on the preprint server AR14, and the paper is yet to be peer-reviewed. Leading researcher Rebecca Larson, an astrophysicist at the University of Texas at Austin, believes there could be many more black holes waiting to be discovered. She expressed that the James Webb Space Telescope is allowing us to explore cosmic history in a way that was previously unimaginable. She's excited to see what else the JWST will reveal, as it is poised to uncover the massive secrets of the universe. Who can say with certainty what other mind-blowing cosmic surprises await us in the vastness of space? The universe is full of privileged experiences just waiting to be unraveled. With each new discovery, we inch closer to unveiling its dark and astounding mysteries. As we dig deeper into the universe, black holes continue to reveal the complex intricacies of our reality. Their formation is not just the result of dying stars. They can also arise from the merging of neutron stars and other massive objects. This cosmic collision leads to remarkable phenomena such as gravitational waves, ripples in space-time detected by observatories like LIGO. These waves provide insights into the violent processes occurring in the universe, including those that create black holes. The search for dark matter also intersects with the hunt for black holes. Dark matter is an elusive substance that makes up a significant portion of the universe's mass, yet it remains elusive to current observational techniques. Some scientists speculate that primordial black holes, which formed soon after the Big Bang, could be responsible for dark matter. If true, this connection could provide a pathway to unlocking one of the universe's most important secrets. But the James Webb Space Telescope isn't limited to studying black holes. It may also observe the atmosphere of exoplanets in perfect detail. By analyzing the light that filters through a planet's atmosphere as it passes in front of its star, researchers can detect chemical signatures indicating the presence of water, methane, and potentially even signs of life. The JWST's infrared capabilities allow it to peer further back in time than ever before, capturing light from the earliest galaxies and stars. This ability is a game-changer for scientists eager to understand galaxy evolution and the conditions that led to the universe we inhabit today. As we continue to push the boundaries of our understanding, the relationship between black holes and the structure of the universe remains a captivating mystery. Every new discovery brings us closer to unraveling the fundamental nature of reality, revealing a universe that is undoubtedly more complex and interconnected than we ever imagined. As we delve deeper into the universe, the James Webb Space Telescope, JWST, is not only offering new insights into black holes and the cosmos, but also unlocking some of the greatest mysteries in astrophysics. With its unprecedented sensitivity, JWST can probe regions of space and time that were once thought beyond reach. For instance, it can observe the formation of galaxies at the very dawn of the universe, mere moments after the Big Bang. This enables scientists to explore how early galaxies developed and how the first stars ignited, shedding light on the processes that gave rise to the universe as we know it. Moreover, JWST's ability to study the environments of distant exoplanets opens up exciting prospects for understanding alien worlds. By analyzing the light that passes through their atmospheres, astronomers hope to detect specific chemical signatures that could indicate the presence of life-supporting conditions. With its advanced infrared technology, the telescope can also peer through thick cosmic dust clouds, offering us a clearer view of star nurseries and the birth of planetary systems. Ultimately, the James Webb Space Telescope is revolutionizing our comprehension of the cosmos, turning speculative theories into observable facts and pushing the boundaries of what we can know about the universe's grand design.